Okay, we're ready to get started on the legs of the character. So let's do that. You will remember that when we're talking about the IK systems in Modo, we have the dual 2D and the full body IK. And the dual 2D has the restriction that it can only be used on chains with 3 joints. Well, 2 joints that will rotate in an nth one. So that represents a problem for the legs and feet of the character because it means that we would have to break the hierarchy right here at the ankle. As you know, right now everything is connected. There is it's a single hierarchy, all the chain. So we need to break it right here so we can use dual 2D for the leg. And then we'd have to see what we do about the foot because we cannot use just 2D IK on this. We're not gonna have a lot of control on how the feet have to bend. And the whole point is we want this to be a single hierarchy because the feet and the legs are connected as one. So moving your leg usually moves your foot. There's not a lot of range of motion we have in our feet independent of the leg. So we want to keep that. And breaking the hierarchy would mean I have to take care of more things to have the feet attached to the leg and all that. The other thing is we have to consider what kind of movement the feet are going to have. So I'm going to display the geometry for a second here. And let's consider how many pivot points the foot has to have. Well, you need to be able to pivot, of course, from the ball of the foot so you can raise the toes or lift the heel while keeping the toes on the ground. We need to pivot from the end of the foot so that you can actually rotate from here as you walk. We need to pivot from the heel and maybe even from the sides of the foot, like this side and this side over here, and from the ankle, of course. So that's lots of pivot points that we're gonna have to take care of. So it's gonna be hard to use the dual to the IK for this purpose. We would need to be able to break this here, and then we can simulate a single joint IK system using a direction constraint. But overall, it's just becoming more complicated. So we're going to be better off using the full body IK system, but we need to see how that works. So let's take a look. I'm going to create a new scene, and I'm going to draw a joint chain that would resemble a leg. So let's say that it was something kind of like this, right? Let's see what that looks like. I'm gonna be a little bit I'm gonna move my joints onto better positions so that we kind of simulate what this would look like if it was indeed a leg. Let's straighten out the knee a little bit. Not gonna go crazy. I just want to give us something nice to work with. And to see the difference, I'm gonna create also a standard 3 joint chain that we're gonna add the IKs, the dual to the IK system too. So with the dual 2D, we've already seen that you get your goal, you move it around, the IK chain follows through, and you can have a pole vector. Well, it's called pole vector in other applications. You can get an up vector to rotate the chain around. So I can just do something like that. Okay, so that's all cool. So now let's take a look at how the full body IK system works. It's a little bit different. It can accomplish the same tasks, and actually it can do more, but it can also be difficult to handle if you don't know exactly which buttons to push. So this video is basically an overview of how the full body IK system works. Not in detail. I'm not going to go over all the parameters because you can find those in the online help system for Modo. You can go and check there. exactly what everything does. I just want to show to you how it works, and then we're going to jump and do stuff right on the character so we can get it to work properly. So the way it works is you just basically select an object at which the full body IK solution will start working. Anything above it in the hierarchy will not be affected by the full body IK, but everything below it will. So it's just going to finish at the end of the hierarchy. It's going to start where you select and finish at the end. And all you do is say assign IK. So when you do that, several things happen. First, you get a new object, which is this one over here, a full body IK item in the scene that, as you can see, is drawing the full body IK chain. So right now, nothing is doing anything. Like, you still have FK control over the hierarchy, but the IK system is in place. Now you need to add goals to it. In the case of the 2D system, the goal is added automatically because there's only going to be one. The entire IK solver is going to have just one goal. But the full body IK system can have many goals that have different goals in the rig, or different tasks. So let's see how we create those. Let's say we wanted to be able to control the position of the leg right from the heel of the character. All you have to do is select the heel. As you can see, we have here our original joint chain, and the full body IK locator is a child of the parent that you had selected before. So we're going to select this guy, and you say add goal. This manually adds a goal to the IK system. And the goals are locators too. In this case, they come pre-shaped as a cube, and they're shaded and colored. And then you can just grab it, and as you can see, the IK system works. You can see that it's flipping too, and it's flipping because we are going past the up vector for this IK system, which is not apparent where it is, but we'll go into that later in the tutorials. So right now, all I want you to be aware of is this is the way you add goals to the full body IK. Now, these goals do two things. They affect position, as you can see over here, but they also affect rotation. So you can rotate anything that is below them in the hierarchy, which is something that the 2D system doesn't do with their goals. Okay, if you want to have additional goals, you can. Let's say that we want one over here. We can add a goal here, and we can add a goal there. Okay, so now we have 3 goals. We can move those independently. You will notice one thing though. The behavior of the entire IK chain right now seems to be averaged, which means that as I move the ankle goal, the joints on the foot try to reach the goals that are on the floor right now. So there is an average weighting system happening right there. I can also notice it. For example, if I select the goal for the toes and I move that, oh, what is that? Well, it's moving the entire leg, which is not exactly what you would expect or want to happen. So we need to see how we're going to prevent this from happening so that I can actually move the feet the way I need it to without disturbing the rest of the leg. Because as you can see right now, well, pretty much any goal is affecting the entire leg system and the feet. So that can be very, very hard to deal with. Fortunately, the full body IK system allows you to change several of its attributes so that you can localize transforms wherever you need them. So I'm going to explain how to do all that once we start to do it in the character. There are other things that you need to be aware of. For example, once you've added goals to a joint, if you go to its properties, you will see this inverse kinematics tab appear. And if you click on it, you will get to all the properties for the full body IK system. And these properties are local to or belong only to that particular joint. So you can change the properties on a per joint basis, even though all of them will have them. Actually, even if they don't have a goal, they have the properties. What changes is you will see that they enable or disable certain properties depending on if they have a goal associated to them or not. For example, you will see that this joint that has no goal assigned to it just has joint properties and then per axis properties assigned to it, which means he can actually work on FK mode. But this joint over here, which has a goal, now has something called tasks. It has a position task and an orientation task. The position task will allow the joint to move with the IK goal, and the orientation task will allow the joint to rotate with the IK goal. So for example, if I don't want this guy to rotate when I rotate the goal, oops, I need to have the goal selected, of course. All you need to do is turn off the orientation task, okay? And once it's off, rotating the goal has no effect on that joint whatsoever. You can also disable the position task if you want. So depending on what you want the joints to do, you would drive those transforms right here. And then you also have per axis enable translation or rotations, use limits, and so on and so forth. So that's pretty much how the IK system works. You could also manually remove or add tasks from the toolbar. With this joint selected, I could get rid of the position task if I don't need it, or the orientation task. I can actually also remove them from the chain. And etc. There's more tools here that you can check on the help file to see what they do. So this concludes our very basic explanation of the full body IK system. And now we're going to use it on our character and see how we can bring the leg to work for us and the foot on something that is called the reverse foot setup. That is something that is going to allow us to have a lot of control and all the multiple pivot points we need for the foot to work. And we're also going to create an auto roll system so that we can actually create walk cycles more easily in our IK rig. So that's a lot of work ahead of us. Let's get started. Okay, we're ready to start working on the legs for our character. So the first thing I'm going to check is that my pivots are all at the right positions. We should have done this at the guide stage, but I noticed when we were watching during the last video that the pivot point for our shoe over here for the tip of the toes is not exactly at the right position. So I'm going to correct that. And if we want to be really strict about following the protocols for this, I should use the guide rig. So let's hide the main rig and show the guide rig. And we can hide all the other controls. Actually, oh yeah, hide. There we go. We can come in and let's grab this guy and let's move him in local space so that he ends up more or less at the point where the shoe will make contact with the ground. And let's rotate a little bit this joint over here. Right now he only has a rotation on the y-axis, so I think I'm gonna just leave him like that. Just make sure that the pivot for the toes is correct, and we're gonna move this guy too. That seems to be better. And now we have to adjust the main rig to follow the guide rig. So let's bring it up. And all we have to do is take this guy. And we want to snap him directly to our friend over here. So let's turn on snapping. And let's snap to pivot points. Let's make sure pivot is enabled. And let's grab the move tool. And there you go. It's snapped. And now this other joint. Again, move tool. You will see that the pivot points are those little pink dots that appear under each item in the scene. So just move in Z until it snaps by itself. And we're done. Let's turn off snapping. We can hide the guide again. And now our rig is good to go. Let's make sure that there's no funny rotations here anywhere. There should be only one axis. This one does have some funny rotation values. So let's zero those out. And same for our friend over here. Let's reset the rotations. That's good. This guy is fine. And him, let's reset the rotations too. And I want to make sure that they are actually, at the same height. That's okay. So let's go back to rigging this. We can hide the geometry now. Let's get started. So the first thing I want to do is isolate the leg from the rest of the rig. So I'm going to do that by using a group locator that I'm going to match to the thigh bone. And let's rename it to GRP our leg. That's going to be our leg parent. So let's go and find this joint in our items list. And he's right there. And he is parented right under the hip bone. So we're going to take our new group and parent it under the hip bone too. And now we can take our thigh joint and move it into this group. So now we have here our joints under that group. Now we can actually assign the IK. So just select the thigh and assign IK. We got this full body IK solver created, so let's rename it to solver R full body IK leg. And we're good to go. So we can start adding our goals to the leg, and we're going to use the same ones that we saw in the previous video, which is one over here at the ankle. So let's just select the first joint for the foot and say add goal, and we're going to rename this to EFFR ankle. We're going to add one for the ball of the foot. Let's say add goal. And we're going to rename this one to EFFR ball foot. And lastly, we're going to create one for the toes. And we're going to rename this guy to EFFR toes. So far so good. Okay, now we have to see what we do about getting these guys to behave properly. So right now, if you move one of these goals, you will notice what we saw in the previous video, that everything is kind of like weighted all the way through the leg. So moving any locator will affect everything. That's not what we want. So let's change a few things for the IK solution. So the first thing I'm going to do is take these two joints, the ball and the toes. Let's go to the IK tab, and over here we're going to disable the orientation tasks because we don't want them to rotate as these guys rotate for now. Okay, and then we're also going to set the number of joints to 2. Right now you can see that it has a value of -1, which means that the particular goal these guys have assigned are going to affect all joints in the hierarchy. That's why we're seeing the behavior we see. However, with a value of 2, only 2 joints will be affected. So now when I move this guy, for example, you can see that the leg stays put. We don't have that problem anymore. And same goes for our friend here. Moving it, as you can see, now moves the toes appropriately. That's the other reason why we disabled the orientation task on these items, because, for example, if I enable it again on this friend, when I move this goal, you will see that it doesn't really reach the goal. And the reason is the joint is trying to both reach the goal I'm moving while at the same time keeping the orientation of the previous goal. So that's not really helping it. So that's why we disabled the orientation tasks. Now it's working correctly. The last thing we're going to do is go to our solver and set the tolerance to a smaller value, 0.1 in our case. That's going to increase the accuracy of the IK solution for the leg. So that's pretty much it, the things we need to do to get the IK set correctly on the leg for now. We still have to rig it because these goals are not doing much at this point. One other thing we can do is refine a little bit how rotations are going to work for these guys. So I can take this joint, for example, and I don't know anybody who can rotate their toes in any other axes, and in this case the y-axis for a character. Anything else would indicate that you basically broke your foot. So let's disable the rotations for X and for Z. So that way he only rotates on Y. And we're going to do the same thing for our knee joint, which is supposed to only rotate in Y2. So there you go. We disabled the other 2 rotation axes. That way it can only rotate on Y. So let's see what we got. As you can see, that's looking a lot better than it did before. And we're ready to start rigging our feet. So let's do that in the next video.